12.4 law of sines. First thing you notice is I have a calculator on the side. We're going to use the calculator for the next 2 lessons a lot. And what we're going to do in these next 2 lessons is solve triangles a couple different ways. The first way we're going to do is called the law of sines. Now before I get to actually how to use it, let's talk about how we're going to write triangles in this case. Now all we're doing here is we've been using a lot of right triangles lately, but now we're going to do any type of triangle. So when let's have a triangle here, something like this. I want you to notice a couple things. First of all, see how my angles are capital letters? So if you have capital letters, it equals angles. So that's an angle there, that's an angle there. Anytime you see a capital letter, it's an angle. Sides are lowercase. I probably should put it like this. Lowercase equals sides. So that lowercase a means side A, a whole side there. Lowercase c is a whole side there. Lowercase b is a whole side there. And another thing I want you to notice is that when you draw a triangle, notice how the angle and the side are always opposite of each other. So here's angle A, it opens up to side A. Angle B opens up to side B. Angle C opens up to side C. So that's always true. If I ever say, let's draw a triangle, it doesn't matter how you label it, but A, B, C, that makes sense as A. This is mean lowercase a, B, lowercase b, and lowercase c. So that's the basics of how we write triangles. Now let's talk about our first formula. That is actually the area of a triangle. Now you remember in grade school how the area of a triangle is 1/2 base times height. Well, that's cute and that's great and all. I mean, it works, but it only works when you have the height. So the triangle I gave you here, there's no height there. You don't see a right angle. You don't see a dotted line. This has a height, but what if I don't give you that? The way we're going to do is we use a separate formula, which we use a separate formula, which uses law of sines, which I haven't really talked about yet, but to get this. Now, and actually, no one ever calls it 1/2 BC sine A. Oh, that's awful. We call it this. This is what I'm going to give you on your formula sheet, on a quiz, anything I give you. Area of a triangle is 1/2 AB sine C. Now, based on the thing we just talked about, notice how it's 2 sides. A and B are both sides. So it's 2 sides. And see how it's sine C? Look at all the things we're doing. Here's A and here's B. There's sine C in between the two. Here's A and here's B. Sine C in between the two. So it's 2 sides and the angle in between. That's all that matters. The letters don't mean a thing. That could be sine of A or sine of B. It doesn't matter. It's 2 sides and angle between. That's the thing that matters. So it's 1/2, 2 sides, and sine of the angle between. That's the area of a triangle now. That's a new one. Again, this one still works if you have a height, but if you don't have a height, this one always works. So 1/2 AB times sine of C, or 2 sides and the angle between. So let's do an example. Find the area of triangle ABC. So draw it real quick. ABC. That's a B, not a 3. That's a triangle, not a curvy thing. If it's your nearest tenth, if angle A, so notice again, capital letter angle, so 31 degrees. You can also tell by the fact there's a degree sign. B is 18, so again, across from B, and C is 22, across from C. Notice I have 2 sides and the angle in between. So I use the area formula, the area of triangle formula. 1/2 AB sine C. Again, the letters don't mean a thing, just 1/2 the 2 sides, 22 and 18. And then sine of the angle in between, which in this case is 31, which you couldn't tell by the way how badly I wrote that. 31 degrees. Then all we do is plug that into our calculator. So turn on your calculator. Now here's the one thing, notice how we have degree signs, so let's make sure we're in degrees. Actually the next 2 lessons we're only pretty much in degrees. So make sure I'm in degrees, and then 0.5 times 22 times 18 times sine of 31. And I get 101.98 meters squared, because area is always squared, in case you didn't know. They want the nearest 10, so I probably should round this, so it'll be 102. Since it's the nearest 10. Move it up. That's a general idea. Let's do one more before we move on. Now look at this one. They give you pretty much every side. They give you 2 sides and an angle. So how do I do here? Well, you pick one of them, right? Here are the two sides I have. And we need the angle between it, like that. So it's going to be 1/2, 4, 30, right? 1/2, AB sine C. Remember, those are just sides, and this is the angle between it. So 4 and 3 are my sides. The angle between it's 30. So sine of 30. Now you can put in your calculator balance. This one I know. 1/2 of 4 is just 2. That's 3. Sine 30, you can put in your calculator, but we know that. We know a 30-degree triangle. 1/2. If you haven't memorized that by now. So I just get 3 meters squared. You can also put in your calculator if you want. So that's the area of a triangle, right? Key thing to keep in mind, it's two sides, any two sides, and an angle between. That's how I find area of a triangle. And don't forget, this one still works. You just need a height. You're not getting the height much anymore. Next, let's talk about law of sines and how to use it. So what law of sines does, it lets you solve a triangle using a combination of sides and angles. So we'll talk about it, but if you have one of these pairs, this is law of sines. A over sine of A equals B over sine of B equals C over sine of C. It works the other way around, sine of A over A, whatever. If you have one of these, if you have what I call a pair, which I mean both A's or both B's or both C's, then you can solve any other one. Now where this formula comes from, it comes from the area formula. And then you can see right here, they just solved it. But that's the law of sines. And if you have a pair, you can set up the proportion and just solve it. So that's when we use the sine rule, pairs. So this is an example. Now right here it says solve triangle NPQ. Anytime I tell you to solve a triangle, that means find everything that's missing. So when they say solve a triangle, they mean find everything that you don't have already. So let's draw this picture. Triangle NPQ. So NPQ, remember it's capital, so lowercase will be small n, small p, and little q. Now I do have P is 42. Angle P is 42 degrees. Q is 65 degrees. And small n is 5. Now, again, so I want to find everything that's missing. I want to find Q because I don't have it. I want to find capital N because I don't have it, which is an angle, right? Because capital letters are all angles. And I want to find side P because I don't have it. I'll tell you right now. Remember, to use law of sines, I need a pair. I actually don't have a pair. I have a P missing, I have an N missing, I have a Q missing. But the first N is actually really easy to find. I have two angles, right? Do you remember how to find the remaining angle? Right, if you add all angles of a triangle, you get 180. So 180 minus 42 minus 65 equals, that's like 107. So this would be 73 degrees. So I found my first angle, I found my N. And more importantly, now I have a pair. I have the ends. So once you have a pair, you start using law of sines. So if we go back to the formula, right, A over sine of A equals blah, 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 or blah, blah, blah. So in this case, I have the end. So let's do 5 over, now very important guys, it's not over 73, it's over sine of 73. A lot of people make that small mistake. So 5 over sine of 73 equals, and then let's solve for anything we want. Let's solve for the p's. Now again, the side goes on top, over sine of 42. Now you can cross multiply, but honestly the easiest thing to do, just multiply both things by the denominator here, right? I want to solve for p, just multiply both things by sine of 42. Put this into your calculator. Sine of 42, those parentheses, times 5, divided by, again, notice I'm in degrees, sine of 73. And I get 3.49. So we get P equals, I'm going to round to the nearest hundredth, 3.4985. So in this case, 3.50, because the hundredth would just give me that. So that's my P. I have one more side. Now some people might be tempted to do Pythagorean theorem. It will not work here. This is not a right triangle, so get that out of your mind. SOHCAHTOA doesn't work. Pythagorean theorem doesn't work. I know it's a sad day. I love those things also. But we're doing a non-right triangle, so none of that stuff anymore. If I want to find my missing q, I gotta go back to law of sines. So in this case, I'm gonna use the exact same proportion. I know 5 over sine of 73. If I want to find q, I'm just gonna do the same thing and put q over sine of 65. Then I'll multiply both sides by sine of 65. Put that into your calculator and you get q equals, let's say I did it right here, 4.74. I'm going to do nearest hundredth. And there you go. You just solved the triangle, right? You found everything else missing. And that's how you use law of sines. Once you get a pair, you have both an angle and its side, you can do law of sines. And just set up the proportions. Let's do another one. I'm going to go this one a little quicker. So same idea here. I want to find everything that's missing. So I got to find, I don't have angle C. I don't have side A. And I don't have side C. I do have a pair already though. I have the B's. Woo! So I could do 9 over sine of 97. Equals, now I can't do the C's, so I have nothing to do with the C's yet, but I could do it, the A's if I want. A over sine of 50. And that's how we talked about. Let's multiply both sides by sine of 50. Again, it's because I had a pair, I had the B's, right? So I can set the proportion. B over sine of B equals A over sine of A. Multiply both sides by that. And A equals 6.95 rounded to the nearest hundredth. So that's my A. Alright, so that's this side right here. Now I said to find any of the C's, and the first easiest thing you can always find is always the remaining angle, right? 180 minus these two always gets you the final angle of a triangle. It's 180 minus 97 minus 50. That would be about 33. Now my C's look the same. Let's say this is capital C. Sorry about that. So now I can find the C's, right? I have a pair already. I have the 9s. I have the B's, as to say. And I have an angle, so now I can find out my missing C. Do the exact same thing. 9 over sine of 33. Sine over 97 equals C over sine of 33. Multiply both sides by that sine of 33. And then you get C equals 4.94, round to the nearest hundredth. So I get that, right? And that's how you solve a triangle using law of sines. Now, those are the easy cases. Law of sines, though, creates an issue. Sometimes you have more than one triangle. It all depends on what they give you. So we call this the ambiguous case. So when they give you two sides and an angle, so SSA, it's written that way on purpose. So if they give you two sides and an angle, then we call that the ambiguous case. You might have one triangle. As you can see here, there's only one triangle based on the stuff they gave me. So one triangle you can make. Also right here. And also right here. But sometimes, if they give you a side that's too small, then you can't even make a triangle. Like there's no solution. It's not possible. And sometimes they give you an angle that's just big enough that you can actually make two angles out of it. So two solutions. So all this is to say is that sometimes when they give you two sides and an angle and two sides and an angle, you want to solve a triangle, you might have no triangles, one triangle, or two triangles. Now the hardest thing is, how do you tell which one it is? Easy way is you don't. You just try to solve. If you have zero triangle, when you try to solve, you're gonna get an error. You're just not gonna be able to solve it. We do all the work we did up there, and it says error on your calculator. That means it probably has no triangles. So try to solve. If it doesn't work, if it does not work, it's 0 triangles. So step 1, how do we know which one it is? Just try to solve it. If it doesn't work, you're gonna have 0 triangles. If it does work, you want to assume there's 2. How do we do that? Well, you do 180 minus the first angle you find. So assume there's 2. So again, if it doesn't work at all, 0 triangles, done. You're done with the problem. 1 and 2 triangles are kind of work the same way. If it does work, you assume there's 2 triangles. So you take 180 out of the first angle you find, and that's gonna be your second triangle. That's triangle 2. If you try to solve triangle 2 and it doesn't work, you only have 1 triangle. If you try to solve triangle 2 and it does work, then you have 2 triangles. And that's the general idea. We're going to do a couple of these. The general idea is this. Just try to solve it. Doesn't work, 0 triangles. If it does work, well, you know for sure you have at least 1 triangle. Assume there's 2. Try to solve for the second triangle. How do you do that? Well, it's very simple. You just do 180 minus the first angle. And that'll be the first angle in your second triangle. And that's triangle 2. Try to solve that one. If it works, you have 2 triangles. If it doesn't work, it's 1 triangle. I know it's a lot. I know. We're gonna do some examples. Hopefully it'll all make sense. So again, determine whether each triangle has 0 nodes, 2 triangles, then solve a triangle. So again, I'm actually gonna do that last because I think the book tells you to do it first. That's an extra step that's not worth it. Let's just solve it. Let's see what happens. So RST. Some respect. So R is 95. Little r is 10, so that's across the way. And then little s is 12. So again, right away, you should notice that I have 2 sides and angles. So this is the ambiguous case. So step 1, just try to solve for the triangle. So do what we normally do. Let's see if we have a pair. I do have the r's. Pair. So I'm going to do 10 over sine of 95 equals 12 over sine of s. Now this one, I'm looking for sine of s. That's on the bottom. So I am going to go ahead and cross multiply. I'm going to get 10 sine of s. It's an s. Trust me. 12 sine of 95. I'm trying to solve for sine of s. So let's divide by 10. I get sine of s equals 12 sine of 95 over 10. I'm plug that all into my calculator. And if you can see what I did right here, I plugged it in my calculator off camera to save you guys time. I get 1.195. Now, based on the last lesson, hopefully that's already going to like something's a little off there. Remember, sine and cosine can't be more than 1 or negative 1, right? So it can't be more than 1 or less than negative 1. It doesn't work. That's going to mean error. And I could try it. Remember how to get rid of sine? Sine inverse both sides. If I do that, sine inverse of my answer here. So I'm just gonna, you can just select the answer. You can just put select the values. It says domain error. That's an error, too big. So if I try to do sine inverse, I get error. So this means no solution, no triangle. So again, just solve it like normal. If it doesn't work, no triangle. By the way, you could actually kind of tell from the very beginning if you're a student enough. Look at the very start, right? 95 degrees goes to 10. Remember, in triangles, there's a rule that says the biggest angle. Like if I said this was 30, that is terrible. Let's go over here. Let's say this is 4, 5, and 8. If I asked you what's the biggest angle, you could tell it would be this one right here, because that's opposite the 8. That has to be the biggest angle. It correlates, biggest angle, biggest side. The smallest angle would be right here, opposite the 4. Smallest side, smallest angle. Look at this. 95 goes to 10. Well, there's a side bigger than 10, 12. Right, so that means the angle here must be bigger than 95. Well, that's already too big, right? If I do like 95 plus an angle bigger than that, I gotta quit. Let's do 95 plus, let's say 96. That's gonna be over 180. Triangle can't be over 180. So I knew right off the bat, this is not gonna be a triangle. That one, that's too big of an angle. It's an obtuse angle. You can't have 2 obtuse angles in a triangle. Let's move on to the next one now. You probably bet this one will be a triangle. Now we'll have one or two sides. That's what we got to find out. So here we go, triangle MNP. So this is M, N, and P. They give you angle N is 32, side N is 7, and side P is 4. So again, notice we have a pair, so we could do log sines. So I have this and this. Pair. Right, so I'm going to do 7 over sine of 32 equals 4 over sine of P. Now you can tell right off the bat, again, this one, the angle's too small. I have no idea what's going to go on here. So, but I do know it's probably going to be a triangle. Is it 1 or 2? That's what we have to figure out. So let's just solve it. Cross multiply sine of P times 7. Put the 7 right here just to make it a little easier to read. 4 sine of 32. Divide this by 7. Putting it, and I get sine of P equals 0.3028 . Now I'm just gonna leave that in there so I can use that value in there. I'm not gonna round it yet. So I have this. Remember, notice it is less than 1, so it will work. We just still gotta get rid of the sign. Remember, the way you get rid of sign is to do sine inverse to both sides. Sine inverse. Sine inverse. So P equals, let's do sine inverse of this. So second sine, select my answer. I get 17.6. 0.63. I like to do hundreds just to make sure. So that's my angle though. Keep that in mind, that's my angle. So P is 17.63. So now, before we move on, let's do triangle 2, because again, the easiest way to tell is if you have two sides and angle, if you have a second triangle, is to assume there is. So let me carve off a little space right here. Let's do triangle 2. So triangle 2 works very similar to triangle 1. This is 7 because I know it's given. Everything I wrote in black is given. So 4, 32. What's different? The first angle I'll give you here, P right here, 17.63. The way you do it here, you have to subtract from 180. Because the idea is, it's not a good picture, but the 17.63 is over here. It's like the summation of it. So let's do 180 minus our 17.63. That's just the rule of getting a second triangle. You just subtract that angle you got from 180. So 162. What do you notice right away though? This is 162, that's 32. Way too big. No triangle 2. So there's only one triangle here. No triangle 2, I should say. Right? Way too big. I have an angle 162 and I already have a 32 there. It's 190. It's too big, so I'm not going to be able to solve that. So, again, that's how you tell if there's 1 or 2 triangles. Right? You solve like normal. If you actually get a value for the first triangle, do 180 minus the first angle, because that's the rule. Just 180 minus the first angle you find. And then you get that exact same angle over here, so this would be like P prime, we call that. And if that makes a triangle, then you have a second triangle. If it doesn't, you don't. You only have one triangle. So over here, we only have one triangle. So now we still got to solve the rest of it. Let's find our missing angle right there. So that's going to be 180 minus 32 minus 17.63. And I get 130.37. So if I want to find little m right there, all I got to do is set it up. Law sign, 7 over sine of 32 equals m over sine of 130.37. Multiply both sides by the bottom here. I'll just do it right here real quick. That's going to be 7 times sine of my answer, close parentheses, divided by sine of 32. And I get 10.06. That's my missing side. So I have solved this triangle. I found the missing angles and the missing side. One last one. Now you probably could guess this one's have 2 triangles. So let's go in and do it. So again, normally we solve it like normal. So make a little thing here. A, B, C. Angle A is 47. Side A is 15. B is 18. I have a pair. Yay. So means we can do law of sines. So I'm going to do 15 over sine of 47 equals 18 over sine of B. Right? Solve it, do a little cross multiplication, blah, blah, blah. Get 15 sine B equals 18 sine 47 divided by 15. Sine B equals 0.8776. Now we're going to do sine inverse to both sides to get rid of the sine. And B equals, sine inverse on that. Again, highlight, select your answer, and select enter. I get 31.36 nearest hundredth. 61, sorry. That is angle B. So 61.36. Now remember, the best way to tell there's two triangles, just pretend there is. Assume there is and see what happens. So I'm going to go over here and let's make our triangle 2. Now remember, the way triangle 2 works is the exact same, all the same gives us triangle 1. So 47, 15, 18. So A, they like to say B prime because it's triangle 2. C prime. Actually just C, not C prime. 47, 15, 18. 47 degrees, 15, and 18. Now, we do have angle B. Right, angle B right there is 61.3. Angle B over here is always the same thing. It's just 180 minus the thing you found, the first angle, the angle you found, the B, the one found the first one. Right, so whatever the first angle you find, just do 180 minus that. And that'll be the first angle you find in another triangle. And I get 118.64. Now if you look at it, 118.64 plus 47 is actually less than 180. So there is two triangles. There will be two triangles in this case. We just got to solve it. So let me actually solve triangle 2 first. So we have that. How do we solve the rest of it? Like we always do. Nothing changes. Let's find C. C is going to equal 180 minus 47 minus 118.64. And this is where you can recheck and see if you have two triangles. 180 minus 47 minus the answer we got. And I get angle C is 14.36 degrees. So see how it actually is an angle? I could find it's not negative. There is two triangles. And I get that from my angle. How do I find my missing side here? Well, law of sines, I have a pair. I'm going to do 15 over sine of 47 equals C over sine 14.36. Multiply both sides by 14.36. I'm guessing like this. Sine of 14.36. I meant. Divide that by sine of 47. Yeah, I hate when that happens. Sine of 47. And I get about 5.09. And that's triangle 2 solved. You got everything for triangle 2. Again, the key thing is, once you find your first angle in triangle 1, assume there's a triangle 2. And this is the only way there's two triangles. So basically, I'm going to ask you, I'll say, hey, this might be an ambiguous case. Is there one or two triangles? So after you find your first angle, do 180 minus it. Then you get your first angle in the other one. You get the B in the other triangle. And then you just solve it like you normally would. If you actually could solve it, then there's two triangles. If you can't, there's only one. Now let's go back up here and let's finish this problem because we haven't found another angle yet. We haven't solved triangle 1. So I have that. We're going to solve C like we always do. 180 minus 61.36 minus 47. So 180 minus 61.36 minus 47. And for C, I get 71.64 in this case. And then we're going to find the missing side for C, just like we did over there. Set up the law of sines. I got pair, so 15 over sine of 47 equals C over, let's put a little c, sine of 71.64. Multiply both sides by that, and we're going to get, let's see, 15 times sine of the answer I got, divided by sine of 47. We get 19.47. And that's how you solve the two triangle case.